So here is question number 16, everyone. A rod of mass m is hinged at upper end capital A as shown in figure. A point object having mass small m strikes at lower end and stops. The maximum angle through which the rod will rotate is. Now the question belongs to dynamics of rotational motion, that is system of particles, an important chapter from NEET point of view. According to law of conservation of angular momentum, the net momentum about this point A must be conserved, or we can say it will be constant throughout. So initial angular momentum Li must be equal to Lf final. Li about A will be mass of object into its velocity into length or distance, MVL. Final will be given as I into omega, where omega is angular velocity with which the rod starts to move. MVL equals I, moment of inertia of rod about point A, given as ml square by 3 multiplied by omega, and after solving we get value of omega as 3v divided by L. Now we got the value of omega. The rod starts to move and reaches at this highest point. Mechanical energy will be conserved, or you can write the total energy initial must be equal to the total energy final. Initially it will have a rotational kinetic energy, that is half I omega square equals, finally if it reaches somewhere here, its rotational kinetic energy is getting converted into potential energy, and that will be written as L by 2 minus of L by 2 cos of theta. Now putting the values of I and omega, we get half ml square by 3 omega square, that is 9v square by L square. Taking L by 2 common, we get 1 minus cos of theta. 2 and 2 gets cancel out, multiplied by mg as well. Here will also mg, that is mgl by 2 minus mgl by 2 cos theta. M gets cancel out, and we get 3v square upon gl equals 1 minus cos theta, and therefore the value of cos theta after solving we get 1 minus 3v square divided by g into L, or theta will be cos inverse 1 minus 3v square divided by g into L. So theta finally, let me write here clearly, cos inverse 1 minus 3v square upon gl. This is our final answer we have got. Now let us find out the option. Option number 1 no, option number 2 yes, it is perfectly matching, so we will go with option number 2 only. Now move on to the next, that is 17 number. So here is question number 17, everyone. On an optical bench, a point object is placed at the mark of 10 cm. A convex lens of focal length 15 cm at the mark of 40 cm, and concave lens of focal length 15 cm at the mark of 60 cm. The final image will be formed at the mark. Now it is given that object and two lenses are coaxial, so we can write here, this is the optical bench, suppose here is the beginning, and this is the mark of 10 cm where a point object O is kept. At the mark of 40 cm, a convex lens of focal length 15 cm is kept. This is the mark of 40 cm. And at the mark of 60 cm, a concave lens of focal length 15 cm is kept. Now where the final image will be formed. First of all, let us see where the image due to this convex lens will be formed. So we can have the lens formula 1 by V minus 1 by U equals 1 by F. After putting the proper sign conventions, we have 1 by V, or we can write V1 minus of 1 by U, that is distance between lens and object is 30 centimeter, so minus 30 equals 1 by 15. Focal length of convex is to taken positive according to sign convention. So therefore we got the value V1 as 30 centimeter. Now the image will be formed at a distance 30 centimeter away from the lens in right direction. Real image, that's why right direction. So 40, 60 mark, here is somewhere the image is formed, means V is, or V1 is somewhere here. Now let's talk about the concave lens. This V1 or final image of convex will act as object for concave. The image formed by convex will act as object for the concave. So therefore here is the object for concave. The distance between object and concave lens is 10 centimeter, and that 10 will be positive because it is in right direction according to sign convention. So for concave lens we have U as plus 10 centimeter. Final image we have to calculate focal length of concave taken negative 15 minus centimeter. Lens formula, let's use 1 by F minus 15 equals 1 by V minus 1 by U, that is 1 by 10. After solving we get the value of V as 30 centimeter. So the image will be formed at a distance 30 centimeter, positive means right direction, from the concave lens. So here is 60 mark and here will be the distance 30 centimeter, means 90 centimeter mark. So the image will be formed at 90 centimeter mark. So we will go with option number 3, which is absolutely correct. Now move on to the next, that is 18 number. So here is question number 18 everyone. A ray of light is incident at an angle 60 degree on one face of prism which has refracting angle of 30 degree. Prism angle 30 degree. The emerging ray deviates through 30 degree from the incident light. So angle of deviation we can take 30 degree. The refractive index of material of the prism will be what? We must be knowing that angle of deviation for a prism is given by I plus E minus of A, where I incidence angle, E emergence angle, that is we can show from here. These are the normals. This is your I, this is your E, and this is prism angle A. So delta, that is 30, equals I, that is 60, plus E minus A, that is 30. We will get E as 0, angle of emergence 0. Now we also know very well that R1 plus R2, angle of refraction and incidence within the prism, always equals refracting angle of the prism. Now since E equal to 0, therefore R2 will also be equal to 0, and hence we get the value of R1, that is A, that is 30 degree. Now let us apply the Snell's law at surface 1 or interface 1. According to Snell's law, sine of incidence upon sine of refraction R1 will be given by refractive index of the second medium, that is refracting, upon incident, that is air here, so mu by 1 we can write. Sine I, sine 60, divided by sine R1, that is sine 30, equals mu, and after solving we get the value of mu as root 3. So we can say that option number 4 is absolutely correct. We'll go with option number 4 only. Now move on to the next, that is 19. Here is question number 19 everyone. Focal length of objective lens and eyepiece of an astronomical telescopes are 200 cm and 10 cm respectively. The length of telescope for maximum magnification will be nearly. Now we know very well, maximum magnification is possible when final image is formed at least distance of distinct vision. So since we know that maximum magnification is possible when final image is formed at least distance of distinct vision. So therefore length of the telescope will be given as FO plus D times FE upon D plus FE. FO and FE are clearly given in the question, so let's plug the values from the question into the expression. We will get 200 plus D, that is 25 into 10 upon 25 plus 10. After solving, we get the value of L as 200 plus 7.14 or about 207 centimeter. So the value of L will be 207 centimeter approx. And if you see the option, we can find that option number 1 is absolutely correct. So we will go with option number 1 only. Now move on to the next, that is 20. Here is question number 20, everyone. In Young's double slit experiment, the slit separation is small d and distance of the screen from the slit is capital D, given that D is much larger than small d. If first dark fringe is formed in front of one of the slit, then the wavelength of light used will be what? Now this is the screen, suppose, and these are the slits. Let us consider, given small d and here it is capital D, and D is much greater than small d. Now the principal maxima formed here. The first minima according to question is formed right here, means in front of a slit, means x1 will be given by D by 2 simply. We know very well the position of dark fringe given as xn, 2n minus 1 lambda capital D divided by 2 small d. So the position for first dark fringe will be x1, that is lambda capital D divided by 2 small d, and according to question x1 is what? D by 2. So better to write D by 2 as lambda capital D upon twice small d, cancel out 2, and therefore we got the value of lambda as D square upon capital D. So this is the value of lambda we get, and option number 4 is perfectly matching, so we'll go with option number 4 only. Move on to the next, that is 21 number.